welcome back. Today we're going to be solving linear systems by elimination. It says part 2 because we're going to be solving systems in a slightly different way than we did on the previous video. In part 1 we solved the linear system looking like this using elimination. Again, notice that the x's are above each other, the y's are lined up one above the other, so are the equal signs, and so are the numbers. This is going to allow us to add the two equations together, and hopefully one of the variables will eliminate. Let's take a look. 4x minus 4x cancel each other out or give us 0. They've been eliminated. Negative 2y, negative y gives us negative 3y. 6 minus 3 gives us 3. We can then solve for y by dividing both sides by negative 3. So we get y equals 3 over negative 3 or negative 1. So we solve for our y value, then we substitute that in, solve for the x, and then check our solution. When we do this, we should get a solution that looks like 1, negative 1. Then we check our solution. And when we check our solution, we found out that 1, negative 1 is indeed our solution. So, what allowed us to do this again was that the x terms canceled each other out. One of them was a positive 4x, the other one was a negative 4x. Let's take a look at another new type of problem which will require us to do something slightly different in order to work out a problem by elimination. Now we're going to solve a linear system that looks like this using elimination. Notice that our x's are lined up, our y's are lined up, so are our equal signs and so are our numbers. You might be tempted to go ahead and just add the two equations together. Let's take a look at what happens when we do this. 6 minus 6 gives us 0. 5y plus 2y gives us 7y. And the 3x and the 4x gives us 7x. Notice that when we add the two equations together, none of the variables were eliminated. The whole purpose to solving by elimination is that one of the variables should be eliminated when we add the two equations together. Since this did not happen, we need to do something to the equations in order to eliminate one of the variables. Now think back to the previous example. What allowed us to get rid of the x's was that one of them was a positive 4x and the other one was a negative 4x. The only thing we're allowed to do is to multiply both equations by a number. So what I'm going to do is I'm going to multiply both of my equations by something so that when I add my two equations together, the x's will cancel out. So I've got a 3x and a 4x. If I multiply the top by negative 4 and the bottom by positive 3, that'll give me negative 12x on top and a positive 12x on bottom. The x's will then cancel. Let's take a look. I'm going to rewrite both equations to the right after I've distributed the numbers that I placed out to the left. So negative 4 times 3, negative 4 times 5, and negative 4 times 6. Negative 4 times 3 is negative 12x. Negative 4 times positive 5y gives us a negative 20y. And negative 4 times positive 6 gives us a negative 24. We can then distribute the 3 into the second equation. So we get 3 times 4 gives us a positive 12x, 3 times 2 gives us a positive 6y, and 3 times negative 6 gives us a negative 18. So when we add our two equations together, we get 12x and a negative 12x. They eliminate or cancel each other out. That's a good sign. That means we've done something right. Now, the negative 20y and the positive 6y gives us negative 14y equal to negative 24 and negative 18 gives us a negative 42. We can continue solving for y by dividing both sides by negative 14, which gives us y is equal to positive 3. Now, the only different thing we've done from this time and the last video is we had to multiply both equations by different numbers so that one of the variables would eliminate. From here, we're just going to follow the same steps we did in elimination previously. In other words, I'm going to take this 3 and I'm going to substitute it in for y into one of the original equations. This will give me 3x plus 5 times 3 equal to 6. 3x plus 15 is going to be equal to 6. And I'm going to subtract 15 from both sides. And it's going to give me, in the end, 3x is equal to 6 minus 15, negative 9. Divide both sides by 3, and we get x is equal to negative 3. So our solution should be negative 3, comma, positive 3. You should check your solution. I'm going to pause the video, or rather you pause the video, check your solution, and then press play when you're ready to see it worked out. I checked both solutions and found out negative 3, comma 3 is indeed our solution. If you'd like to have steps to look at while you're working through a problem that requires many steps, I went ahead and wrote the steps out for you. You pick a variable to eliminate, you multiply one or both equations to make the coefficients the same, but different signs, sort of like when we got the 12 and the negative 12. Then we combine the equations. Note that the important part here is that one of the variables should be eliminated. Then we're going to solve for the remaining variable, substitute, solve for the other variable, and then check our solution. Go ahead and try to solve the system by elimination on your own, pressing pause, so when you're ready to see the answer, please press play. Now you can solve this linear system by eliminating either of the variables. I'm going to work it both ways so that you can see which way you like best. If you chose to eliminate the x's first, you would have had to multiply the top equation by negative 5 and the bottom equation by positive 6. This is going to give us a negative 30x. Negative 5 times negative 2y gives us a plus 10y. And negative 5 times positive 8 gives us a negative 40. Distributing the bottom equation, we get 30x plus 6y is equal to a positive 24. When we combine our two equations, the negative 30x and the positive 30x cancel out. Now that's exactly what we want to have happen. One of the variables should go away or be eliminated. That leaves us with just 10y and 6y, which is 16y, is equal to negative 40 plus 24 is a negative 16. We can then divide both sides by 16, giving us y is equal to negative 1. Now that we have the y value, we can substitute that y value into either equation and solve for x. I'm going to substitute the negative 1 into the top equation, giving me 6x minus 2 times negative 1, or plus 2, is equal to 8. I then subtract 2 from both sides, and I get 6x is equal to 6. I can divide both sides by 6, giving me x is equal to 1. So my solution should be 1, comma, negative 1. Now, as usual, you should check your solution. However, I'm going to solve by eliminating the y's first this time, so that you can see it done slightly differently. We should still end up with 1, comma, negative 1, and then I'll check my answer after solving it the other way. Again, which variable you choose to eliminate is your choice. If you chose to eliminate the y's first, the process is actually going to be a lot simpler. Sometimes it is, sometimes it's not. We need to make negative 2y and a positive 1y the same number but different signs. Now, they're already different signs. So all I have to do is multiply the bottom equation by 2, and the top equation, well, I can leave it alone or multiply it by 1. Same effect. This gives me 6x minus 2y is equal to positive 8. So I just rewrote the top equation. The bottom equation, I get 10x plus 2y is equal to positive 8. Now, again, the reason I could do this is because I needed to make the negative 2y and the positive 1y the same coefficient but different signs. Did we accomplish this by multiplying the bottom equation by 2? Well, yes, we did, because we have a negative 2y on top and a positive 2y on bottom. So when I add my two equations together, I'm going to get 16x, and the y's will cancel out or eliminate. Give me 16x equals equal to 16. We can divide both sides by 16, and we get x is equal to 1. Now, just like before, we know the value of x, so we're going to substitute that in. We get 6 times 1 minus 2y equal to 8. 6 minus 2y is equal to 8. Subtract 6 from both sides. We get negative 2y is equal to 2. Divide both sides by negative 2. And we get y is equal to negative 1. So our solution should be 1 comma negative 1. Notice that either variable we chose to eliminate first, both of them rather, gave us the same solution, and that should happen. Now I'm going to go ahead and check my solution. You can press pause, check it out for yourself, and press play when you're ready to see the answer. I checked my answer and found out that 1 comma negative 1 was indeed the solution. Here's some additional problems for you to try on your own. Go ahead and press pause, working the problems out, and press play when you're ready to see the answers. In these examples, one of them is going to have infinite solutions and one of them is going to have no solutions, and the other one's going to have one solution, which we will have to find. I want to give you this as a reminder of what we did in the previous video. Again, go ahead and work these out, pressing pause, and press play when you're ready to see the answer. I went ahead and got all the equations to the point of elimination, and on the left side equation, notice the x's and the y's cancel, leaving us with nothing, or 0 on the left-hand side, and 14 plus 5 is 19. Remember, that's not a true statement. 0 does not equal 19 when we solve the equation, so there's no solution to that first set of equations. For the second one, 28x plus 15x gives us 43x. The y's cancel out, leaving us with negative 48 plus 5, which is a negative 43. We can solve for x in this one, and we will here in a second. For the third equation, the x's and the y's canceled out, giving us 0. And notice the numbers also canceled, giving us 0. 0 does equal 0, so in this case there are infinite solutions, because we were left with a true statement when we tried to solve the equation. So that leaves just the middle equation to solve for. If you didn't already get that, go ahead and pause the video, work it out the rest of the way, and press play when you're ready to see the answer. I ended up getting negative 1 comma negative 1 is my solution. If you didn't already check it out, check that out on your own, and make sure that negative 1 comma negative 1 does indeed give you a true statement. When I checked it out, negative 1 did work for both of our equations in that middle system. So we did find our solution.